Hello, I'm going to provide a solution for number 18, which was requested by some students. So, on a site plan for a new house, a water main runs along the edge of a property straight from point W1034. So W1034 is right there, to point M22, which is there. The water service will enter the house at point 2422, which is right there. The grid on the plan represents 0.5 meters. So at what point on the water main should the connector take water to the house be located? Explain your reasoning. Well, the rationale here is that we want to use as little pipe as possible. So what I'm going to do is I'm going to just kind of draw on this diagram. Let's extend this water main up here. I'm going to want to connect this such that we have a 90-degree angle between the connected pipe and the water main. So therefore, if that's the case, and we need to find this point here, we want to use as little pipe as possible. Therefore, the new pipe connecting the house and water main should be perpendicular to the water main. So let's read that again and make sure we understand it. We want to use as little pipe as possible, so therefore the new pipe connecting the house and the water main should be perpendicular to the water main. So there's my house, here's my water main, this should intersect at 90 degrees. So that means that if we want to find the point at where this new pipe intersects with the water main, I can think of this as a systems of equations problem. If we think of the water main as line 1 and we think of my new pipe as line 2, we can get the equations of those two lines and then find the point of intersection. So what we're going to do with this problem is we're going to find L1 and L2 and find point of intersection. So let's work at L1 in green just to kind of help show our work here. I'm a big fan of color coding answers. So if I know that L1 has the point W and M on it, we can find the slope WM, and the slope of WM is going to be 34 minus 2. So the change in y, 34 minus 2 over 10 minus 2, which is going to give me 32 over 8. And 32 over 8 wonderfully works out to 4. So we can see the slope of this is 4. So therefore, we know that for L1, we can say that y is equal to 4x plus b. Of course, I need to find b. So we're going to sub, and we can pick either w or m here. I'm going to sub an m because it's smaller numbers. Sub m, which is 2, 2, to find b. So therefore, 2 is equal to 4 times 2 plus b. 2 is equal to 8 plus b. So therefore, b is equal to negative 6. So L1 is y equals 4x minus 6. And I feel good about this because if I extend this green line, it should be a negative y-intercept. So now let's work with L2 in blue, since L2 is already blue. So again, L2, well, if we want the slope, so we know that since L1 and L2 are perpendicular, that is, they intersect at 90 degrees, we can see that the slope of L2 is equal to negative 1 over the slope of L1 So that's equal to negative 1 over 4. So therefore, for L2, we can say that y is equal to negative 1 over 4x plus b. And of course, now I have to find b again. So we're going to sub in. And let's use 24, 22. That is the point H to find b. So 22 is equal to negative 1 over 4 times 24 plus b. Do a little rearranging here, 24. So 22 is equal to minus 6 plus b. So b is equal to 22 plus 6, which is 28. So again, I come back to my graph and I look and I say, do I feel good about that? And let's see, so if we take a look at this, b is 28. Now, my line is such that it comes up like this. So it doesn't look nice based on the graph. However, I don't know if this is necessarily where it's going to cross. It might be here. Remember, is this the scale? This isn't the scale, bear in mind. So this isn't necessarily an accurate drawing. So I'm going to go back and let's just check our work. So the slope of line 1 is 4. And so therefore the slope of line 2 is negative 1 over 4. So we take the point of the house, which is 24, 22, which is right here, and we substitute it in. So 24 divided by 4 is 6, and the y value is 22. And that seems to work. So even though it doesn't look right here, it's because the scale is off in our diagram, or the diagram that's provided. So therefore, we can say that L2 is y equals negative 1 over 4x. And then plus 28. So now that I have these two lines, I'm going to find this point of intersection. Probably going to have to give myself some more space under here. Yeah, the last problem that's been requested is below there, so let's give myself some more space. There we go. Keep coming down a bit more. Okay, so that means I'm going to take my system, and let's just change colors again, just to keep things flowing here. So we know that L1 is y equals 4x plus, let's scroll up, 4x minus 6. And we know that L2 is y equals negative 1 over 4x plus 28. So substitution works perfectly here because they're already isolated for y. So 4x minus 6 equals negative 1 over 4x plus 28. I'm going to clear my fractions to get rid of that 4 in the denominator, so I'll multiply each term by 4. So 16x minus 24 is equal to minus x plus 28 times 4 is 112. So now we'll just do a little bit of algebra here. So we have 16x, and then we're going to add x to both sides, equals 112, and we'll add 24 to both sides. So 17x is equal to 112 plus 24, which is 136. And let's see if this question is nice. Oh, look at that. It works out to a nice x. X is 8. So if x is 8, we're going to sub x equals 8 into, let's say, into L1. So y is equal to 4 times 8 minus 6. And we can work that out. And we get 26. So therefore, the new pipe connects at 8, 26. And let's just scroll up now, make sure that makes sense. There's 10, so it's got to be somewhere on this side, and 26 is somewhere around here. Okay. Now it's really important to point out that this diagram is not to scale, so it doesn't look right based on what I've drawn here. So it's really important to always check that scale there. So part B is, what is the length of the pipe of connection that will be required? So this turns into a pretty straightforward distance of a line segment problem now. So let's do B over here. So the house is located at 2422. And the pipe is, the pipe connection point, did they give that a letter? No, let's call it P. The pipe connection point is 826. So therefore, all we have to do is find the distance between these two. So we use our distance formula. So I'm going to say 24 minus 8 squared plus 22 minus 26 squared. Right? So the square root of 24 minus 8 is going to be 16 squared plus 22 minus 26 is minus 4 squared. 16 squared is 256 plus 16, 256 plus 16, we get 272. And this is a case where I would totally rewrite this as a decimal because of the fact that this is some length that I need to have a concept of its actual length. And root 272 isn't going to make sense to a lot of people. So I need about 16.49 meters of pipe. Okay. So let's just go back and walk through this one again. So the idea here is that I have this water main pipe, which is my green, and I have a house located here. I want to connect it to the water main. So I want to use as little pipe as possible, meaning that the shortest distance from a point to a line is 90 degrees. So I connect those. And again, I take note that this diagram isn't to scale. So this isn't going to be perfect. So essentially what I do is I figure out the green line. For line 1, I figure out the blue line, which is line 2, and we can do that here. So we find the slope of line 1. We sub a point to find the y-intercept. We use the slope of line 1 to find the slope of line 2. They should be negative reciprocals. Then we sub a point to find the y-intercept. And then to find the point where the house connects to the pipe, we just find that point of intersection between those two lines. And then part B is what length of pipe do we need, and we simply use the distance formula. So we say x2 minus x1 squared plus y2 minus y1. So 24 minus 8 squared plus 22 minus 26 squared, and we work that out, and we get about 16.49 meters. So therefore, we need 16.49 meters. I hope that helped.